Hello, we are Group 4. This is our arena simulation model for the emergency room simulation project. Our objective was to model the flow of patients ranging from critical 1s to non-critical 5s, and identifying bottlenecks to reduce waiting times and length of stay. So our first assumption was that patients would arrive at an exponential time with a mean of 9 minutes. We also had assumed all route times for our ER will be about 1 minute. So they enter the front desk through a route from the front door. Then they'll assign patient levels, and based on these patient levels, they'll assign the entity pictures as well as the priority for queues. Lowest levels will have first priority in the queue. Then we have an LWBS, and our assumption for LWBS is that critical patients from level 1 and 2 will stay in a bed, will only stay if a bed is immediately available, while less critical patients will leave if the queue for a bed, such as L5, will leave if the queue is 8 or more, L4 will leave if the queue is 9 or more, and L3 will leave if the queue is 10 or more. Additionally, we have a special addition specifically for fast tracking because the limit isn't able to be limited by beds since they are not required to have beds for L3 to L5. So for those L3 to L5, we also require that the resources for physician and RNs be less than 1 and 2 respectively. Then if they succeed and don't have to be ejected out of our system, or rather they don't leave because there's not enough capacity, then L1 will skip the triage, and L3 and L4 and L5 will go to triage. Then they will assign an ER time for calculations and then go en route to the ER ward. The green areas are fast tracking, the yellow areas are for POC, and then the magenta areas for looping, which is a special scenario that we decided to test but has a minimal impact. So they go through the ER ward, they're assigned a bed, and they get their first RN visit. And this is our base model. They do not go through the green or the yellows for the base. And then they get the physician assessment and the diagnostic probabilities, and they'll see which testing they'll need. Then they are routed to the decision for testing for lab, testing for x-rays, and testing for CT, and they will complete those and get their attributes and process times for each one. Then once they're done, they will get routed to the nurse's office for privacy, and they'll get the second RN visit and some extra calculations for turnaround, where we would then finally dismiss them by routing them to the front desk, giving them a mid-process, and then having them exit the system. Additional assumptions is that for POC, the resource beds will be released after the lab, and the patients will go to the lab prior to all testing needed. Also, we assume all ER waiting areas to have unlimited capacity. That means there will be no limitations besides beds, excluding for fast tracking. And then we assume that the length of stay begins when they enter the ER ward.
Hello, my name is Daniel Wiener, and I'm going to demonstrate to you the ER hospital system simulations in Arena, particularly the animation for it. So first off, the patient arrives from this parking lot, as you can tell with all the ambulances and cars. So they arrive and they go through this entry door. And then after they enter, they go to the front desk registration where the patient is registered into the hospital. There may be a brief queue depending on the availability of the registration clerk. After this, the patient heads on to the waiting zone where they may have a seat, and also a nurse goes and is assigned to a patient where the nurse assigns the patient a triage level, L1 through L5, and this triage level determines the priority of the treatment and whether the patient qualifies for fast track and any expected resource usage. Then the patient is determined whether they are LWBS or not, and what that means is if wait times exceed thresholds such as queue length or wait time, then the model will mark the patient as a LWBS, where the patient will briefly leave the system through the same door that they came through. So after all of that, the patient goes into the bed treatment area where they have their first RN visit, and also a physician evaluates the patient, and the patient will be given a bed and will remain in bed awaiting for labs, x-ray, and CT. So after that, the patient will either go to the x-ray, CT, or lab, depending on the diagnostics from the physician, and then they will go to that particular place, and they will be tested on and undergo scanning and any other medical procedures. And after the patient goes through either one of these three, then they head on over to the office where they will have a second RN visit, And the second RN visit is a follow up assessment, and it's where the patient's clinical check is finalized and reviewed. And during this, the patient is either admitted or discharged. So if a patient is admitted, then they go to this door over here, this upstairs door further into the hospital. And if the patient is discharged, then they exit and head on back out to the parking lots. And I'm going to show you what all of this looks like in real time. So as you can see, the patient goes through the entry to the front desk registration, waiting zone, bed treatment, and either goes to X-ray, CT, or lab. After that, then the patient will go to the office and then exit. So yes, here's the animation.
Hi, I'm Dave. I'll be explaining the performance measures in our ER, which are displayed in this integrated dashboard. So to make monitoring passing days in the simulation easier, we set the date to January 1st, 2000. We have also included the time variable uh, representing the real passing of time in the simulation. We have time statistics in our right, here displaying the average length of stay for both admit and discharge. It also has the average time for lab turnarounds, which are the time the patient begins the lab process up until the second RN visit, which the lab results are handed out. To our left, we have patient volume. The graph shows plotting the both patients discharged and admitted. And it also has the throughput, which is the cumulative sum of both of them. And we also have the left without being seen plot right here, which is plotting the LWBS count. And we also reported the percentage of it. And just like in time statistics, we break down the variables into, well, to display each value for each triage level. At the bottom, we have resource utilization and Q metrics. Utilization can be visually interpreted by the number of busy resources displayed by the level animations over here, like this. And also the utilization rate is available for every resource. Um, as for Q, we display the number of patients in queue and average waiting time for every resource. Some of the resources like RN and admit clerk have two sets of Q metrics indicating different states of when the resources are busy.
Hi, I'm Musa. Before running our improvement scenarios, we first made sure our model had enough replications. The project recommended 10, but when we first tested that, the 95 confidence interval was still too wide. So to make our results more reliable, we increased the run setup to 30 replications, which gave us stable and consistent output. Next, we used the process analyzer to run all of the required scenarios. So we had a baseline, then we had scenarios where we added two more physicians, and then we added four more beds and fast tracking level 4 and 5, point of care, lab testing, triage nurse, and then combination of A and B and E. We evaluated all scenarios using same 30 replication setup. We also tested our diagnostic routing logic, which we call looping. So looping determines how the patients who need both X-ray and CT are routed. With looping on, the model chooses the fast option based on queue length. With looping off, patients follow a fixed order. To compare both versions, we ran 31 scenarios with looping off and then 31 scenarios with looping on. When we looked at the results something together, we found something important. The best scenario depends on which metric you care about. So if your priority is reducing LWS, then the scenario 64 is the best one since it has a LWS percentage of 0.058. But if the priority is treating the highest number of patients, then scenario 15, as you can see, is the best one since the number of people are is 3,709, which is the biggest one. So different scenarios optimize different objectives. The recommendation depend on whether the ER wants to focus on minimizing the LWS or maximizing throughput or any other different variable they want to focus on.